Hello everyone, this is Miss Chelsea and today we will be discussing pure substances and mixtures. Our standard for the day is S8P1A, which is to develop and use models to compare and contrast pure substances, which are elements and compounds, with mixtures. Let's consider the following. What are pure substances? Well, pure substances are elements or compounds. They have definite physical and chemical properties. These properties can include physical appearance as well as chemical reactivity. All pure substances are made up of one type of particle. It can be an element or a compound. They cannot be broken down by physical changes, so a chemical change would be required to break the bonds. Let's identify each of the following as a pure substance or mixture. Well, soda has a bunch of ingredients listed out that are mixed together. Therefore, it is a mixture. Air has multiple types of elements and or compounds. So you'll find nitrogen and oxygen in the air as well as water and carbon dioxide. That makes air a mixture. Helium, on the other hand, is on the periodic table. It is an element and therefore a pure substance. Chlorine is also on the periodic table, so it is also a pure substance. And finally, cold medicine has a few different active and or inactive ingredients, therefore it is a mixture. But we already know that both elements and compounds are examples of pure substances. But how can we further classify mixtures? Well, mixtures can be divided into two categories. Homogeneous mixtures, with the Greek root homo meaning same, are the same throughout. They have a uniform composition. For example, orange juice without pulp. Heterogeneous mixtures, on the other hand, with the root hetero meaning different, are not the same throughout. They do not have a uniform composition. So something like a mixed salad, trail mix, anything like that. Let's try some examples. Identify if the following mixtures are homogeneous or heterogeneous. Let's consider honey. Honey by itself, without the comb, is homogeneous because you can take honey from different parts of the jar and it will still look the same. If you look at spaghetti with meatballs, you can see the difference between the spaghetti and the meatballs. So that is heterogeneous. Chocolate ice cream is homogeneous because it all looks the same. However, if you were to have chocolate chunk or chocolate chip ice cream, then it would be heterogeneous. You have to have something that you can see separate in order for it to be heterogeneous. So blood is homogeneous and soil is heterogeneous with all the different parts it has, like rocks and the dirt itself and the little bits of decomposing plants. Now, keep in mind that heterogeneous mixtures can further be classified as colloids or suspensions, with colloids being heterogeneous mixtures that contain tiny particles that will not settle out when they're left to sit. For example, paint or milk. Even though it looks homogeneous, it's actually heterogeneous because of the tiny parts that you can see on a more microscopic level. Suspensions, on the other hand, are heterogeneous mixtures that have large particles that can easily be seen and distributed. So if you think about salad dressing, you leave it in your fridge for a while, it's going to separate into different layers with different parts. Not to mention something like muddy water will do the same. Solutions are another name for homogeneous mixtures in which one substance is dissolved into another. For example, tea or air. So solutions are truly homogeneous. Colloids have such tiny particles that they appear to be homogeneous even though they're heterogeneous. And suspensions are obviously heterogeneous. So here's the example of the colloid paint, suspension salad dressing, and solution of tea. Now to wrap up this topic, let's think back to the container of salt and trail mix. Knowing what you know about pure substances and mixtures, how could you separate the sodium and the chlorine in the salt and the trail mix into its individual parts?